Hello everyone, myself Praveen Pathak. I am postgraduate in chemical engineering. I am going to discuss the basics of chemical engineering thermodynamics. So it is impossible to cover all the basic concepts in a single video or lecture. So I have divided these basic concepts of chemical engineering thermodynamics in a series of lectures. So this is the first lecture of thermodynamics, in which I am going to discuss about the thermodynamic systems and equilibrium. So what exactly the thermodynamic means? Thermo means heat and dynamics means moving. So whatever the operations, reactions involved in the industries or laboratories which are related with the heat are called as thermodynamics, and the scope of this thermodynamic is nothing but to study the for all forms of energy and the interconversion of different forms of energy, that is heat is converted into chemical or vice versa, and like that. So it gives the condition how far a given process may proceed and whether the process is feasible or not feasible, and it can calculate the energy requirements in the process. It also calculate or the perform the energy balances which are required in unit of operations or process. It also determines the conditions of equilibrium. It also determines the various physical properties. It also measures the heat evolved during the combustion of all types of fuels. It also determines the states of phase and chemical equilibrium necessary for the design of separation units. The overall, the thermodynamic applications are in fuel technology, power sector, chemical engineering, renewable energy, etc. What is the limitation of the thermodynamic? It does not tell us how fast a given process will occur. It does tell us how far a given process will occur, but it does not tell us how fast, that is the rate of reaction, right? The second thing or second limitation is it says nothing about the reaction mechanism, whether the reaction is occur in single step, two step, three step, etc. It does not give us an idea regarding the resistance to flow of energy or transfer of energy. How much resistance is there, which resistance is there, etc. It does not tell us about the actual work requirement of the process. It does tell us only the minimum work requirement of the process. It does not provide deep insight into physical and chemical phenomena. That is, it does not go into the details of the chemical phenomena or physical phenomena at micro level. It does not give any idea regarding the character of the process by which the change in state takes place. Through it provides a quantitative description of the overall changes in the state. So this is regarding the scope and limitations of the thermodynamics. Now there are different terminologies involved in this thermodynamics. One of the terminologies is system, second is surrounding, universe and boundary. So these are the basic terminologies in thermodynamics. So the specified portion of the universe containing the quantity or a substance or a group of substance is called as system. Remaining portion of the universe other than the system is called as surrounding. And the real or imaginary surface which separates the system and surrounding is called as boundary. And the combination of this system and surrounding is nothing but the universe. These are the basic main four concepts involved in the thermodynamics. Then the other concept is process. A system changes from one state to another is nothing but the process. And the properties involved in the system are called as thermodynamic properties. So thermodynamic related properties are nothing but the thermodynamic properties. For example, pressure, volume and temperature. So this is explained in this picture, that is system, surrounding and boundary, and some other examples like closed system, open system, isolated system and thermodynamic system. So in the next terminologies point, there are types of systems. So we studied the system. Now there are types, that is open system, closed system, isolated system, adiabatic system, homogeneous system and heterogeneous system. So what exactly the open system is? A system which can exchange matter as well as energy with its surrounding. So in this picture it shows mass in and mass out and energy in and energy out. So matter as well as energy is transferred from through the system, that is why it is called as open system. In a closed system, only energy can transfer through the system and not the matter. In the isolated system, neither energy nor matter is transferred. In the adiabatic system, it is insulated thermally from the surrounding, that is called as adiabatic system. And there are other two types of system, that is homogeneous and heterogeneous system. A system consisting of a single phase is called as homogeneous system, and a system consisting of more than one phase is called as heterogeneous system. So hetero means different or more than one. Then other concepts are extensive properties and intensive properties. What is extensive property? The properties of a system which depends on the mass. For example, volume, moles, mass, internal energy, enthalpy, entropy, heat, capacity. And what is intensive property? The properties of a system which are independent of the mass are called as intensive properties. For example, temperature, pressure, specific volume, density, specific heat, molar volume, viscosity, thermal conductivity, etc. Please note that the enthalpy, entropy are the examples of extensive property, and molar enthalpy and molar entropy are the examples of intensive properties. Then there are thermodynamic processes like isothermal, isochoric, isobaric, adiabatic, cyclic, reversible, irreversible and quasi-statics. So what is meant by isothermal? When the temperature is constant. Thermal means heat. Heat is measured in terms of temperature. When the temperature is constant, then it is called as isothermal. Isochoric. Choric means constant volume. Isobaric. So baric means at constant pressure. And when no heat leaves or enters into the system, then it is called as adiabatic system. Then cyclic system. When the process undergone by a system, as a result of which the system is returned to its initial state through the cycle. So it is nothing but the cyclic process. And if a process in which the direction at any stage can be reversed, then it is called as reversible process, in which the infinitesimally slow speed is there, the driving force is also infinitesimally greater than the opposing force. Exactly reverse in the case of irreversible process. In irreversible process, the system or process can't be carried out in reverse order. That is why it is called as irreversible process. Then last one is the quasi-static process. Quasi means near to and static means equilibrium. So if the process is near to equilibrium, then it is called as quasi-static process. What is the difference between this reversible and irreversible process? In reversible process, in ideal and imaginary process, and in irreversible process, it is actual or real process. In reversible process, it takes infinite time for its completion, but in irreversible process, it takes an finite time for its completion. In reversible process, it is extremely slow, and in irreversible, it is fast. In reversible, it takes place with infinite assembly small driving force. In irreversible process, it takes place with a finite assembly. In reversible, during the process, the system passes through equilibrium states, and in irreversible, it passes through non-equilibrium states. It can be plotted on thermodynamic coordinates in reversible. It cannot be plotted on thermodynamic coordinates. Thermodynamic coordinates means pressure, volume and temperatures. In reversible process, work done is in reversible process, is greater than that of irreversible process, and in irreversible it is vice versa. Then reversible process, there are no dissipative effects. In irreversible process there are dissipative effects. In reversible process, the example is motion without friction. So there is no friction. And in irreversible process, the motion with friction is the example. Then there are types of equilibrium. So equilibrium means near about balancing. So there are three types of equilibrium initially, and other types of also there. So first is stable equilibrium, second is unstable, and third is metastable. The stable equilibrium is nothing but the system when goes towards the stability when large disturbances are there. Even after the large disturbances, the system is going to achieve original equilibrium. Then it is called as stable equilibrium. And unstable equilibrium, when small disturbances are there, still the new equilibrium is achieved instead of original equilibrium, then it is called as unstable equilibrium. And the metastable is in between the stable equilibrium and unstable equilibrium. So if the large disturbances are there, then new equilibrium can be achieved, and if small disturbances are there, the original state or equilibrium can be achieved in the metastable equilibrium. So this is represented in the sketch: stable, unstable, and metastable. Then other types of equilibriums are thermal equilibrium, chemical equilibrium, mechanical equilibrium, and thermodynamic equilibrium. So in the thermal equilibrium there is no flow of heat from one portion to another. In chemical equilibrium, if the composition or the concentration is uniform throughout the equilibrium, then it is called as chemical equilibrium. And in the mechanical equilibrium, generally we are saying that no imbalance of forces or the pressure is constant, then it is called as mechanical equilibrium. If in a system all these three, that is thermal equilibrium, chemical equilibrium, and mechanical equilibrium are achieved, then it is called as thermodynamic equilibrium. The other concept is thermodynamic function. So there are two types of function. One is state function, second is path function. What is state function? The function which does not depend on the path or the way is called as state function. For example, pressure, volume, temperature, enthalpy, entropy, etc. And if the function is depend on the path followed, then it is called as path function. For example, heat and work. So this is represented by the A, B, and C path for the path function. So initial state is R, final state is S. So from R to S we can go through A, we can go through B, we can go through C. If from R to S, if only P1, T1 and T2 is considered, then it is called a state function. If the path A or B or C is considered, then it is called as function. The last point or concept is nothing but the macroscopic view or approach. So micro and macro are the different terminologies. In the macroscopic view, we consider system as a whole and not the microscopic structures or the matters. For example, water in a beaker is a system, then we are going to study the water as a whole and not the water molecules, right? So for studying the microscopic approach, micro, then we have to study the large number of molecules with different positions, velocity, energy at a given instant of time. But normally for diploma or degree level of chemical engineering, we are going to study the macroscopic view or approach for the thermodynamic systems. Thank you.